Comets formed 4.5 billion years ago when the sun and our planets were still just a big, hot cloud of primitive space crud. Now, planets and asteroids have changed a lot over the years because of things like solar radiation, collisions, and plate tectonics. But comets are almost perfectly preserved. These lumps of icy rock and dust came from the Kuiper Belt, a region out past Pluto. They're so far from the sun that they're deep frozen, and there's not much else around to interact with. So they're basically windows into the earliest days of our solar system. And around 20 years ago, NASA scientists wanted to get their hands on some comet dust. So they launched the Stardust mission to study the comet Wild 2. The Stardust spacecraft launched from the Kennedy Space Center in February 1999, and its payload parachuted back to Earth in January 2006. Basically, the spacecraft was a brick of scientific instruments, about the size of a big desk, with a solar panel sticking out of each side. It was designed to get up close and personal to the comet Wild 2, so it could take some pictures and capture thousands of dust particles in a specially designed collector. And as you might imagine, this wasn't so easy. First of all, comets are fast. If you want to catch up to a comet, you're going to need to be moving over 46,000 kilometers per hour. The rockets we use to send stuff into low Earth orbit only go about half that fast. So we had to double the speed of the spacecraft, even though it had the same kind of propulsion technology, specifically rockets with ultra-pure hydrazine as the propellant. And to do this, NASA scientists used Earth's gravity like a slingshot. They sent the Stardust spacecraft to orbit around the sun, passing close enough to Earth to pick up a speed boost and adjust its orbit. By its third pass around the sun, the spacecraft was going just fast enough to fly by Wild 2, some 240 kilometers from the comet's surface, which is still in the cloud of dust surrounding its icy, rocky center. So that's how they caught up to the comet, but how did they get the dust? Those dust particles were moving about 6 times faster than a bullet fired out of a rifle relative to the Stardust spacecraft. If they just tried to scoop all that dust up with a regular old instrument, all the speed and the heat from the impact would probably destroy the dust particles. So the scientists made a special collector that looked kind of like a big, spacey tennis racket. It was round and flat and had a grid of cells that were full of this cool material called aerogel. Aerogel is 1,000 times less dense than glass, and certain kinds provide 39 times more insulation than the very best fiberglass. In other words, it's kind of like a super strong, super light sponge. So when the dust particles from Wild 2 hit the aerogel, they were just kind of dragged to a stop and stayed intact. The trails the particles left through the aerogel helped scientists find them, since some were only a few microns across. As a bonus, the collector had a second side, which was used twice during the trip to Wild 2 to catch interstellar dust, scattered particles of matter floating around in space, which can help us better understand what interstellar space is like. I mean, you can't let half a fancy aerogel-filled collector go to waste. When the Stardust craft looped back around close to Earth after a 4.6 billion kilometer journey, it dropped the capsule with the collector over Utah. Samples of comet dust were distributed to about 150 scientists around the world, and scans of the interstellar dust were released to hundreds more citizen scientists. And these data are still being studied even today. In 2014, for example, NASA announced that 7 of the particles collected by the Stardust mission possibly came from supernovae of distant stars, which flung them into our solar system. And in 2009, researchers discovered one of the simple organic compounds that makes up proteins, the amino acid glycine, in one of the Wild 2 samples. There has been some debate over whether the glycine in the sample was from Wild 2. It could have been contamination from Earth. But glycine has since been discovered on another comet thanks to instruments on the Rosetta probe, which suggests that maybe the building blocks for life on Earth actually came from comets in space. And I mean, if we could get our starter pack of chemicals from comets and end up with like Madame Curie's and Taylor Swift's, maybe some other planet could do it too. Thank you for watching this episode of SciShow Space, and thanks especially to our patrons on Patreon who help make this show possible.